Hi.
Hi, welcome to Porotech.
And please introduce yourself.
So I'm Tong Tongzhu, I'm the CEO and founder of Porotech. We are a UK-based international global company providing micro-LED technologies, platforms for everyone, including big displays and small displays, transparent displays and flexible displays, all the way to head-up displays and AR applications. So we are a global design house for micro-LED solutions worldwide. So this is a flexible 27-inch micro-LED based technology display using RGB, all colors coming from a single material system, indium gallium nitride. So you can see the color and image quality coming from a unified material system with high quality, high brightness and resolution as well. Oh, sorry.
What's the dot pitch happening here?
So this one is a 1.27 millimeter pitch using TFT backplane. But RGB pixels coming from a single material system. And here we're looking at a transparent display, 7.5 inch, 34 ppi full color using mini LED based on TFT backplane. There you can see the transparency as well as the brightness required for outdoor applications.
Is this ready for prime time? And what's it called, like mass production and everything?
So these are the reference designs open for everyone to have an evaluation. So these are open for evaluation and testing. So our purpose is to provide the platforms and the supply chain for manufacturing, but tailored to customers' requirements and system specifications. So now we are coming to another booth that we are on.
You got People's Choice?
Yes, we just won the People's Choice Award for the best micro-LED based technology, because we have the world's all-in-one solution. LED gives all the brightness and the colors. So here we're looking at a full color resolution and solution for the optical projector system, based on three panels coming from a single indium gallium nitride material system. So the brightness levels can reach 1 million nits, D65 bright, for the outdoor applications, but three panels, because of the unified material, now you can have optical and electrical characteristics all the same. So the power management, power consumption are also unified.
Is it possible that your technology will enable my future smartphone to have a really awesome full table touch display?
So we are very open.
Projection.
Yes, so we are very open in terms of the application areas, but we primarily focusing on AR applications and head-up displays that are less than 1 inch, and small wearables, as well as a large TV and signage applications. But of course, for all kinds of different user cases and application areas, we are very confident micro-LED can open up new doors for all kinds of user cases as well.
All right. And what do we see here?
So here we are seeing a wide portfolio of different applications, from 0.12 inch monochrome applications with pure red, pure green applications based on indium gallium nitride with high brightness and efficiency that is guaranteed the small form factor required for AR glasses applications. That's super duper very tiny and small, but still brightness.
In the glass?
Yes.
Through the waveguide and everything?
Yes, that's correct.
How bright will it get?
So we have millions of nits for red and blue and green.
Millions?
Yeah.
Right.
And these are also 0.26 reference designs, and that we are mass producing, launching after this event with single colors, blue and green and red, also with millions of nits in terms of the brightness, but 720p. That are going to be enabling wider content providing as well as the field of view for AR applications. And on the top, we are looking at some dynamic pixel tuning, full color resolution, all colors coming from a single panel. So without further complication of the processing manufacturing, we are utilizing one LED that we are able to provide all the colors.
One LED to do all the colors?
Yes, yes. But of course, these are the reference design that we are providing as a platform technology and reference design for everyone to improve and build upon based on their specifications. So we are able to provide all the functionality, but not on the system level, because the system will be tailored to every single application. But in terms of functionality-wise, we are almost there.
So what's the resolution on this 0.2?
So 0.2 inch diagonal, we have 720p, 1280 720p, so more than 5,600 ppi resolution.
That's very high pixel density, no?
Yes.
Sorry, I tried to catch it. Ooh,
It's very difficult to video and take any photos even.
it's so bright. My sensor is going to survive this?
I'm sure you will be okay. Yeah.
All right. Because how far are you from mass producing all this?
So the mass production of 0.26 is happening currently in Taiwan, which is our branch. So we have an 8-inch production line from material all the way to pixel to CMOS and hybrid bonding all the way to wafer level optics, including the light engine assembly. Everything is happening in Taiwan using standardized process flow and standardized reputable suppliers for the manufacturing. Because we are a design house, basically we have the key technologies and key components and designs that we are utilizing the semiconductor production throughput to make the fabrication on 8-inch. So everything is happening in Taiwan on 8-inch.
Millions of nits is insane. I was expecting 10,000 would be enough. Somebody's comment.
Right, okay. So basically, we are actually providing the sufficient brightness for all kinds of application, because every process flow that we'll be reducing, including the optics and the light engine assembly, that will be keep cutting down the needs. That's essentially we're providing the enough sufficient brightness for all kinds of applications, including outdoor and indoor, and that can be adapted to all kinds of waveguides, and especially the diffractive waveguides that's required for the augmented reality. So higher brightness is necessary, but you don't necessarily have to have those other pixels lighting up all the time.
Ask Porotech if we will see their micro LEDs in Vuzix glasses.
I would say it's potentially possible. I wouldn't be able to comment on that, but I think we are open and working with everyone in the industry and partners and customers, trying to bring those micro LED on the market as soon as possible.
Wondering what company are already using those screens, especially VR and AR market?
So obviously we are trying as fast as possible to bring those on the market, but we are in the very closely working relationship with all our partners and customers, trying to build prototypes and development kits, and all the way to small volume productions as we speak. So hopefully in another 6 to 9 months there will be some early prototypes and glasses incorporating our products and technology.
And you call it DPT?
Yes, dynamic pixel tuning.
Dynamic. Does that mean that when you talk about millions of nits, you can have it as kind of like a peak brightness?
Yes.
Only sometimes?
Yes, yes. So
for not so long?
Well, you don't have to light up all the pixels all the time, consuming a lot of power. So there is a lot of flexibility that we are providing for the end user or system designer in terms of unifying or utilizing our design and platform technology to be able to have a wider flexibility for the system level optimization. So in terms of you don't necessarily have to have all the functionality, but according to the user case and the environment that you're in, you will be much better off in terms of adapting our dynamic pixel tuning technology.
And is it true? I wasn't here at Display Week last year. I wasn't allowed to travel to the US. But is it true you win iZone?
Yeah, we won the
and now
best.
You have a huge booth.
That's correct.
That means iZone's work.
Well, yes, but also we keep our momentum building up gradually, and we are growing internationally as well. So we won the best prototype award last year in the iZone in Display Week. But this year we just won the People's Choice Award for the best micro LED technology. So that is a motivation for us to keep going much quickly and bring this micro LED as a commercial product. So,
is it automatic that the winner of the iZone gets a big booth next year?
Not necessarily, but we wish to have the best exposure and best working relationship, open our doors and open business working with everyone. Because obviously we are a small company, we have to have the partnership.
So how do you do?
Yes, very good.
You do okay? Do you understand what we're doing here?
Yeah, it sounds pretty revolutionary. In the future, is everybody going to have this technology? It's going to be just normal?
This is the only way to do it.
I hope so. Yeah.
Stacking 3 layers of epi RGB is just not going to work. So give up and come join us.
All right.
Yes, that's right. Yeah. Thank you, Mike.
So did you just say that other people are stacking?
Yeah, other people are stacking, doing quantum dot color conversion, which will introduce complexity and you losing process steps. So we are using the existing technology and production process flow, but we are innovating on the material level, solving all the problems on the material level, but knowing what we are building and problems that we're solving, but utilizing the manufacturing that is so standard in the silicon world that will guarantee the economics.
Where every LED is full color, potentially.
Yes, so in other words, you don't need to know which LED is emitting at what wavelengths before you give it a signal, before you give it a content. So that's how, that you have a much better off in terms of the system level and calibration of the display when you are doing the calibration step. So that will consume less power and simplifying the processing flow for the manufacturing. So that is, unfortunately, the only way forward to make micro LED a commercial product.
But you're talking about TV also?
Yes, yes.
You will make the TV.
So, so for the AR and head-up display, obviously we're providing the entire system and display panels as well. But for the large TVM, large panel displays, unfortunately we can't change how the panel makers doing their process flow, but we are able to provide the best chips for them to make their panels and satisfying their customers. So for this case, we're providing the red, blue and green chips for them to assemble into a panel using whatever TFT or glass-based backplanes, but we are providing the efficiency benefits and cost benefits.
Can you also be the kind of like multicolor, full color backlight for as a mini LED?
Yes, we can.
Kind of
yes,
backlight?
We can. Yes.
For the LCD?
Yes, yeah, that's exactly what we are trying to solve the problem, because for some outdoor signage applications, because brightness is the issue, power consumption is the issue, but also the viewing angle is the issue. By unifying all the colors in a single chip, that will be simplifying a lot on the optical and the end level system design. So that guarantees the best user experience for whatever application down the road.
Because when you talk about the AR, VR stuff, and when you talk about TV, it's different size.
Yes.
And so it must be different factories.
Yes, so for the AR applications which require CMOS standard application, because we have to use the CMOS backplane, so that we are utilizing an 8-inch production line in Taiwan. For making large TV and large panels, we are working very closely with the panel makers, enabling they have their products and commercialization plans very quickly. So they have their existing, so that's how we work with them, by selling the best chips. It's because they have the backplane, they have the mass transfer technology, but we're providing the best chips.
So 10, 12 years ago, I had the Kopin GoldenEye, and there was Google Glass 10 years ago. I was so excited, but somebody stopped it. And then Facebook changed the company to VR, the name, and there's a rumor that the Apple company is going to launch something. So it could be exciting time in the future, right?
Yes.
And
definitely.
you think you will be busy?
Yes, definitely. So we are a true believer of micro LED. Obviously, micro LED can be a display component, but we truly believe that every single pixel of those micro LED can be a display component, because they can be individually controlled and emitting brightness and functionality. But actually, you got millions of pixels right here on a CMOS chip that can be actually functioning much beyond in terms of functionality, beyond the display component. So
how do you compare performance of your transparent compared to transparent OLED?
So we are targeting more than 80% transmission using micro LEDs, because micro LEDs are semiconductors that are transparent by nature. But we are also working very closely with glass makers and utilizing micro ICs, so that will eliminating a lot of metal interconnects. So that guarantees more than 80% transmission for future.
That's more than the OLED transparency?
Yes, much higher than.
Much higher?
Yeah. So the OLED is currently at 40-50% transparency just because of the metal lines. But we can eliminate all of those metal lines simply because micro LED is much smaller but also transparent.
And those 20% that you lose, let's say I'm imagining the future Cybertruck Tesla design, something. And I want to have windows that have a little bit tint when I'm not activating full entertainment or advertising mode. And then boom, it can switch into
That's
all
correct.
the windows.
Yes.
are entertaining you, all of you like riding in a VR.
Yes, that's correct. Yeah, and especially when every single pixel can be dynamically controlled, so you can have the information and content whichever and wherever you want on the panel. You don't necessarily have to, because obviously you still have to interact with the environment. So what I can see in the future in terms of autonomous driving, you can not only entertain yourself, but also you can interact with the outside world through that magic and digital windscreen in front of you as well.
One thing that would be awesome is if you help also make it affordable to billions of people, not just people who are very rich. Because I don't know how much the Apple VR is going to cost, but it'd be nice if there was some technology that was affordable to everybody.
Absolutely. So that's how that's why we are insisting on making micro-LED happening in the silicon manufacturing mindset and establishment, because we're utilizing existing capacity, existing throughput and processing flow. There's no introduction and additional funding required for the manufacturing setup. So we are using fully depreciated and legacy technology for the manufacturing that is guarantee the economics and cost reduction for this micro-LED adoption in the future.
That brightness will be great for pancake lenses.
Yes, it is going to be working with all kinds of optical designs. So the idea is we're providing all kinds of the brightness and the efficiency and performance that's needed for all kinds of the user cases and the specifications. So whether it's AR, VR, XR or head-up display, whether it's commercial, consumer, enterprise application, we have all the solution ready.
I've heard of amazing display technologies before where they said, we are able to do something that can just do a small change in the LCD, huge LCD factories, and maybe they can make them.
Yep.
Sometimes it's a great promise, but still a small change is still something that scares the $5 billion investment or whatever is behind.
Yes. Yeah.
Can you promise that the changes you're talking about make sense, it's not so expensive? Or
yes, so it's not just the promise, it's actually the action that we're taking in real life in terms of working with panel makers, utilizing their legacy technology, but also working very closely with silicon foundries and legacy technology production lines for the manufacturing. So it's not just that we are providing the technology platform, but we're actually taking every step to guarantee the manufacturability and cost basis that's going to be affordable for everyone in the future.
And all these problems that some technologies have with burn-in, it's not with the micro-LED.
It's not. It's a semiconductor device. When it's off, and it's guaranteed to be a transparent. So you don't have to fake the transparency as well as you don't have to fake the black. So when it's off, it's a semiconductor device. It's off. You don't consume any power and electricity. So that's the nature of the semiconductor device. That is guarantee the differentiation between OLED and our technology.
Are there a bunch of optical tricks you can do to not require perfect yields and still sell everything?
Yes.
Even there's a few dots.
Exactly. So
and people will not see them somehow?
Yes. So there's many different ways that you can improve yield to have 4 nines, 5 nines, but we propose that you don't have to do that, because you can make micro-LEDs much smaller but still benefit the efficiency and brightness. When the pixels are getting smaller and the PPIs are much higher, so we can be more tolerant with the yield. So when there are dead pixels or dead dyes that you can forget about them, you don't have to the visibility. But in the meantime, we can make redundancies when the pixels are getting smaller. So you can redundant them using software update. So that's a much similar mindset and philosophy that we are using in the CMOS industry.
And you are a Taiwan company?
We are based in the UK. We are a UK entity, but we have a UK branch. We have a Taiwan branch. Yeah.
But you want to work with everybody in the world?
Yes, exactly. So we're international.
Matter if it's in Europe, in US, in Asia.
So
everywhere.
exactly. So we have a global supply chain for all kinds of customers and different applications. We have a UK, Europe, and US supply chain to be able to work with that side of the continent. But we also have a Taiwan supply chain working with the Asian customer and manufacturing base as well.
So you could work with fabs that are anywhere.
Yes, exactly. And
there are some nice display fabs in the US?
Yes. We are working with everyone, and we are talking to all kinds of different partnerships that can guarantee our customers will have their products, not just in the prototyping phase, but also in the mass production phase.
And another little question is, I'm just a YouTuber, but often I'm like, how soon? And sometimes it takes many years, and I grow older and stuff. It'd be nice to. How soon is it like people will go and buy it, and it's not expensive, and they can just buy it.
Yes, so you can see the trajectory that we as a company have been growing over the last 3 years, so we are very young. So although obviously the frustration people have been enjoyed about the micro LED promise over the last 7 years, I do get the feeling of that, but because we are here, we are very innovative in the material and the way that we are doing the manufacturing, so we can be quite positive, and I think we can bring some fresh air into the industry that micro LED is coming. Although I can't give you a definite timeline for that, but I think it's going to be happening very, very soon. I hope in the next 12 to 18 months, hopefully, some products will be landing on the market with consumer testing and buying and testing them out there in the field.
Hello, I'm Mr. Beast. No, I'm not Mr. Beast actually. But if I was Mr. Beast and if I was sending you a bunch of money, I would use Wise. Wise is a really smart way to send money around the world. Tiny little fees. Check out my video, a 7-minute video where I try to explain some more. It works in hundreds of countries. Every time you go to a different country, use your Wise card or use your Android Pay, your Apple Pay to do all your payments with a tiny little conversion fee. If you have some customers in different countries, they can send you money to local bank accounts in the US, in Europe, all over the world. You can get local bank account details. They transfer tiny little fees. Don't use PayPal anymore. Don't use Western Union. And don't use your bank to send money, because it's surprising, but you wouldn't know maybe, but they take fees that are gigantic, that are pretty big. Just use the Wise. It's smart.